In this problem, we are asked to find the equivalent resistance, current, and voltage drops across each resistor and the battery. So, here's our parallel circuit. We know it's parallel because there's more than one path. There's a junction right here, it splits, and there's another junction down here. So we've identified it's a parallel circuit. We're going to follow the steps for solving a parallel circuit. The first step is to find the equivalent resistance. Now, remember, for a parallel circuit, the equivalent resistance equation is 1 over the equivalent resistance is equal to 1 over the resistance of the first plus 1 over the resistance of the second, and so on and so forth. In this case, we only have 2 resistors. So now we can go ahead and substitute in. So we've got 1 over the equivalent resistance is equal to 1 over 2 plus 1 over 4. Okay, got our 2 ohms from the first resistor and our 4 ohms from the second resistor. Now we need to add. Remember, when you add fractions, the denominator must be the same. Okay, so what's the common denominator here? Well, I can make the common denominator 4. Okay, so this 1/2 would be 2 over 4. Now we've got a common denominator, and so we can go ahead and add. So 2 over 4 plus 1 over 4 is 3/4. So we end up with 1 over our equivalent resistance is equal to 3/4. But we're not done yet. We need to solve for the equivalent resistance. This is 1 over the equivalent resistance. So there's a couple ways you could do this, but one way that you learned to solve proportions in math class was by cross multiplying. So I'm going to go ahead and multiply 1 times 4, and I'll get 4. And then I'll multiply the equivalent resistance times 3, and I get the equivalent resistance times 3. Divide both sides by 3. And we end up with 4/3 is equal to the equivalent resistance. We can leave it as a fraction. You could make it a decimal. In this case, it's just going to be 1.3 repeating. So since it repeats for a while, I'm going to go ahead and just leave it as the fraction for now. All right, so we found the equivalent resistance. Now remember, the equivalent resistance is what the resistance would be if we were to combine these and make it 1. It's also the resistance at the battery. So we're going to go ahead and write the equivalent resistance is equal to 4/3 ohms. And now we're ready to start the next step. Find the current. Okay, so we need to find the current. The only place that we can find the current right now is at the battery. Okay, we don't have enough information anywhere else. So we're going to go over here to the battery, and we're going to say voltage is equal to current times resistance, Ohm's law. So 6 is equal to the current, which we do not know, times 4/3. And then we need to solve, so we can divide both sides by 4/3, or multiply by the reciprocal, 3/4. And we have the current is equal to 18 over 4, which we know reduces to 9 over 2. And if you want, you could write this as a decimal. This one at least ends, so it's a little bit better if you're going to use a decimal. But you can leave it as a fraction as well. So the current here is 9/2, or 4.5 amps. The next step is to simply recall that all the voltages are the same. Since each resistor is connected to the potential difference, they have the same voltage or voltage drop across them. So the voltage here is 6 volts, and the voltage here at resistor 2 is 6 volts. Find the current through each resistor. Okay, so let's find the current through the first resistor. Again, use Ohm's law. The voltage at the first is equal to the current at the first times the resistance at the first. So 6 is equal to the current times the resistance, which is 2. Divide both sides by 2. Our current is 3 amps. And then we've got the last one. So our voltage is again 6 volts. Our current is what we're trying to find, current 2. And then we need resistance 2, which is 4 ohms divided by 4. That reduces to 3/2 amps. Or if we want to write it as a fraction, this would be 1.5 amps. And now, if we recall from our notes, we can check our work using Kirchhoff's current law, which says that the current at the battery is going to be the sum of these ones. So the current going into this junction, because in this case it's the current of the battery going into the junction here, is the same as the sum of the currents coming out. So it's equal to current 1 plus current 2. So we've got 4.5 is equal to 3 plus 1.5. 4.5 is equal to 4.5, and our work checks.